Hi, welcome back to another episode of Algebra in Words, the video series on YouTube. What we're going to look at today is continuing our discussion with radicals, and we're going to be looking at solving radical equations. Before we start, if you want to follow along in written form of what we're going to go over, in terms of the steps and procedures that we're going to use today, as well as some other examples, you can see that starting on page 78 in my book, Algebra in Words 2, which you can find on Amazon, and the link to that is in the description box below. So let's get started. What I have on the board here are 4 examples of radical equations. What are radical equations? They're simply equations with radicals in it. And if I had to summarize the major key to solving radical equations, it's basically using the proper strategies to get rid of the radical, and then you basically just solve the rest for x like you normally would using basic algebra. So I have 3 problems on the board here on the left side, and I have them for a reason, to show you a certain pattern. And the pattern is to show you the proper steps to get rid of each type of radical. If you notice before we start, one is the square root, one is the cube root, and one is the fourth root. So the way to get rid of the radical properly is you want to get the radical alone on one side of the equation, which in these 3 examples they are, and then you want to raise both sides to the power that's the same as the root. So if we look at the first one, since it's the square root, we're going to square both sides. And the reason behind that is because if you remember, when you have a radical where the root and the power are the same, it eliminates the radical and you're left with the base, what's inside. And then whatever happens on the right, make sure you apply the proper power. So on the left, the square root of 3z squared equals the base, or the radicand, 3z. So let's write that here. And 6 squared is 36. Now, since we want to solve for a z, and we have a coefficient 3, we're going to divide both sides by coefficient 3. And 36 divided by 3 is 12. Z equals 12. Now, that's the answer, but you always want to check your answer for radicals by taking whatever you purport the answer to be, substitute it back into the original equation, and simplify as much as possible, and make sure that the left side equals the right side. If it doesn't, or if it makes what's under the radical for even roots become a negative radicand, remember, you can't take the even root of a negative radicand, so if that ever happens in the check step, you have to say no solution for that number that you're testing. Now, in the first problem, we squared both sides because we had the square root. If we look at the next problem, and I'm going to just erase this for a little room. If we look at the next problem, we have a cube root. So we're going to cube both sides. Raising a cube root to the power of 3 makes the radical get eliminated, and we're left with just the base, which in this case is a binomial, x minus 4. And on the right, 2 cubed is 8. Now we're going to solve for x by just adding 4 to both sides. And in this problem, also coincidentally as the last one, x equals 12. And again, remember to check that by taking the original, substituting it back into taking your answer and substituting it back into the original, simplifying, and testing. Now let's look at the last one. We have the fourth root of x equals 3. And since this is the fourth root, we're going to raise both sides by the power of 4. And the reason is because the fourth root of a radical raised to the 4th power eliminates the radical and leaves you with the base or the radicand, in this case x, and on the right, 3 to the 4th equals 81, and that's it. Just to summarize the strategy here, notice that if you have the square root, you square both sides. If you have a cube root, you cube both sides. And if you have the 4th root, you take it to you raise every side to the power of 4. And hopefully you see the pattern that to get rid of a radical, you raise the radical to the power so it's the same as the root, and what you do to the left side, do the same to the right side. Now, in these 3 examples, the radical was already isolated by itself on one side. But you could have problems where it's not isolated, such as this one here. And that's fine. All we have to do then is a preliminary step to isolate the radical. So let's do that now. And since we have plus 2 on the left side with the radical, then let's subtract 2 from both sides and rewrite it. So we have the square root of 2x plus 5 is now equal to 3. And I'm just going to erase this old work so we have some room to finish the problem. Once again, since we have a square root, we're going to raise that radical to the power of 2 and also raise the other side to the power of 2 as well. So when we square both sides, the radical on the left gets eliminated and we're left with just what's underneath, 2x plus 5, and 3 squared is 9. Now we're just going to solve for x. Subtract 5 from both sides. Two x equals 4, and let's divide both sides by coefficient 2. And we get x equals 2. And I'm not going to go through the full check step, but you should be able to do that on your own. But just to get you started, what you would want to do is take your solution, what you think is the solution, and substitute it back into the original. That would be here. And simplify all the way down and make sure that by the end the left side equals the right side. And if it does, that means that the answer that you have is correct. So I'm going to pause the video and put another problem on the board. Okay, I put one more problem on the board, and it is negative the square root of x plus 7 minus 1 equals negative 7. And we're going to use the same strategy as we used in the last problem. Now remember, if the radical is not alone, we want to make it alone on one side. So right now it has the minus 1 as well as a negative in front of the radical. So we want to get rid of those first. Let's start by adding 1 to both sides. And that leaves us with negative the square root of x plus 7 equals negative 6. And we do want to get rid of the negative in front of the radical too. So let's divide both sides by negative 1. And that changed the signs on both sides. Now we have the square root of x plus 7 is equal to 6. And we want to get rid of the radical. And how do we do that? Well, since this is the square root, we want to square both sides. And we square both sides mainly because we want to square the square root. That gets rid of the radical, leaving now x plus 7. And 6 squared is 36. Subtract 7 from both sides. And x equals 29. And before we circle that, you should substitute that back into the original equation and simplify and make sure the left side equals the right side. If you do that, you'll find out it checks out, and That's the answer. Now, in this video, we looked at radical equations that had one radical in each equation. But you could also have problems that have two radicals in each equation. And I'm going to stop this video and we're going to go over that in the next video.